If I get corona, I get corona. At the end of the day, I'm not gonna let it stop me from teaching computer science. I've been waiting for the spring break for a while. For 2 months I had these lectures planned, 2 or 3 months. I'm just out of here having a good time. I hope you guys know what I was referring to. I was referring to that college student who was saying that partying is much more important for him than coronavirus.
If I get corona, I get corona. At the end of the day, I'm not gonna let it stop me from partying.
Which I'm not sure if you know, but he recently had to apologize for. So he said that, he said sorry, for the comments. He was mostly apologizing for the insensitive comments versus the actions, the partying and the spreading the coronavirus. Okay, so I definitely don't want to defend him. What he did was absolutely. There has to be politically correct phrase here. His actions seemed immature. Oh, perfect. Politically correct phrase. Yeah, so his actions seemed immature, but at the same time though, that's the most honest answer which you can expect. You catching a person in the middle of doing something bad, and what is he supposed to say? So so many students, what are they supposed to say if you expected some honest answer? That was the most honest answer. For me personally, he said, what he meant was coronavirus is not as important as having fun. The coronavirus was exaggerated for him personally, in his opinion, right? It's not that dangerous, and he's just have been planning that trip for so long. Why would I have to postpone that? Why would I have to do anything with it? In his opinion, again, his opinion. And that was super honest, super honest. And he had to apologize for that. And it's interesting again because in the text he said I apologize for the actions, but the severity of the comments, that was the worst thing. And he just got unlucky, in my opinion. He got on the news, and that was the first thing in that section of the news piece, right? So there were so many people talking about it, but the way he said it, was eye-catching. It was a bold statement. If I get corona, I get corona, and then it just got spread out everywhere. And but again, he was super honest, and there were so many people doing that, but he was unlucky and he got attention. Yeah. I have a question, by the way. So those people who were editing the news, okay, so they know that they shoot for NBC, CBS, that channel. They know that a lot of people will be watching that. They also know that nobody is going to support this guy, right? So nobody's going to support that thing when you say I don't care about the disease which the whole world is going down for. Okay, nobody's going to support that. So if he's 21, if he's partying at the Miami Beach, he's probably drinking. If he's drinking, he's probably 21 years old. Well, let's say he's 21 years old. If he's 21 years old, he's probably senior or junior, which means he's probably graduating soon. And now he got on the news, and he became so popular. Okay, so if people who were editing the news, if the point was to show that there are college students who don't listen, or let's say the government has not, or the colleges, the Miami government did not do good enough job to keep them safe, if that was the point of the news, then they wouldn't have to put his name out there. So the people who were editing, right? My question is, how moral, how sensitive is that they put his name out there, they put the very, very strong statement first, right? Out of all the interviews, they put his face first, his statement first, right? And he had some sunburn, he's not in the best shape. So they were demoralizing that person, the guy, and they put his name out there, they put his name, okay? So how moral is that? If he's graduating soon, he may not be able to find a job because of that. If there was no name, at least, if the face was changed, the voice was changed, then they'll be fine. And that would still make the point that the college students are not listening, they don't care about the coronavirus. And even if they put exactly the same phrase, right? But they put his face there, they put his name there. And now when a company is about to hire him, they'll probably run a background check, and where is his name gonna pop up? Good luck starting a career. So my question is, how moral, how sensitive is that? Because I know I know that making that point was not the purpose. The purpose is to get as many views as possible. How do you do that? You just like get the phrase out of the context. Okay, so like you need to create something like eye-catching. You need to create something which will draw attention. Because I remember I was giving interviews to TV as well. So they would, usually the way it goes is that they would ask you like that many questions, let's say 10, and then we'll just like cut it and edit, and we'll pull something out of the context, and hopefully that'll be like exactly what you meant. He might have been talking there for I don't know, 20 minutes, 10 minutes, and he might have said a huge amount of different stuff, but they pulled out like a very, very tiny, like one, I don't know, 3 sentences, and which completely demoralized him. And now he showed him from a horrible perspective. So my question would be to those people who are editing that, how sensitive is it? And how moral, how ethical is that? Anyway, lecture number 21, let's roll the intro. Today we're talking about Dangler references and garbage collection, maybe a little bit, and a couple of ways garbage collection is done in the heap. Okay, so I already typed some notes. Let's take a look here. So when a heap-based allocated object is no longer alive, a long-running program needs to reclaim the object space. Okay, so again, or if you, let's say you have a huge program, right? Some object was created. There is a pointer to that object, and then you destroy that. And then let's say you're not using the object anymore, and it's a very, very big question. So how do you know if the object is not used anymore? Okay, how do you know if it's useless? It's actually a very big question. But maybe like you think it's useless, but actually the user is going to use that, or like some other crafty ways to actually keep something like in some memory. Maybe it'll be used, but maybe it'll be used like, I don't know, like in half a year. Anyway, so you need to reclaim that object space, right? The stack objects are reclaimed automatically as a part of the subroutine calling sequence. But what about the heap, right? So how are the heap objects are reclaimed? By the way, keep in mind that starting from this week, you need to submit the lecture and the notes from the lectures as well for the homework. So on Monday, when you'll be submitting the homework, I'll ask you to submit the notes as well. So how are the heap objects reclaimed? There are 2 alternatives. Languages like Pascal, C, C++ required to reclaim an object explicitly. So basically either garbage collection or explicitly to do that. In Pascal, you would have to say dispose myPtr, where myPtr is the pointer to the object which was allocated on the heap. Then in C, you would have to say free, and then myPtr. In C++, you would have to say delete myPtr. Okay. A dangling reference is a live pointer. You guys already know that, but let's repeat. A live pointer that no longer points to a valid object. Languages like Agol 68, there should be a space, or C, which allow programmer to create pointers to stack objects. A dangling reference may be created when a subroutine returns, while some pointer in a wider scope still refers to the local object of that subroutine. Let's take a look at the example. So again, we're talking about C, right? So int I is equal to 3. Okay, now int star p. I hope you guys remember from that online resource I gave you how the pointers are created. So let's say if I say int star p, that means I created p, which is a pointer to an integer. Okay, so how do we know it's a pointer? Because of the star. What does it point to? It points to an integer because we say int. Okay, so by itself, if I print out p, what is it going to locate? It's going to locate what a pointer usually locates. It's going to print out the address. It's going to print out an address of some integer. So yeah, but when I say star p, if I print out star p, it's going to go to that location in the memory, grab that number, grab that integer, and print that out. Okay, so let's say if I want to, if I want p to have the address if I want P to be pointing to that 3. So I want this P to be pointing at that 3. So the way I would write that code is I would say int star P is equal to, if I say 3, that means the address which will be in P will be equal to 3. But I don't need 3, right? So I don't need I need the location of I, which is done using this, like, what is it called? Ampersand, right? Yeah, ampersand. Yeah, ampersand. Anyway, so I means the integer number, which is 3. Ampersand I means the address of I, so it'll be like 0xFFF, like 7A, the location in the memory, right? P by itself means the address. Star P means like what's located at the address, unless except for the moments, except for the lines when we're creating the pointer. So after this moment, after that, if I print out P, it's going to print out the location, right? It's going to print out some address. If I print out star P, it's going to print out whatever is located at that address. So basically, I want if I want P to point at I, that's the code I need to use. Okay. Anyway, so P points at I. Okay. Now let's say sometime later I create a void. I create a function void foo. Okay. And then let's say it doesn't have any parameters. And then here I create. Let's say here I create. Okay, let me write here. Int n is equal to 5. P is equal to address of n. Okay, P is equal to address of n. Okay, so now instead of P pointing to I, P, since P is global, yeah, keep in mind that this P is this P, right? It's a global variable. Okay, it's not a local, it's a global variable. So in here, P points to I. If I run foo, then n, the variable n is being created, then P starts pointing at n. Okay, so address of n. And then, yeah, and then, check this out. Then, in the main file, let's say in the main. Yeah, let's say in the main file. If I do something like cout, so it's basically like a system.out.println, but in C++. Cout star P, it's going to print out what? It's going to print out 3, okay? Because I did not call this foo yet, okay? That was created by default. That was executed when the like with the object file. So again, since those are the global variables, they're declared first. They're created first, okay? So that's why star P actually prints out 3. But then if I execute foo, okay, and I do the same thing, what do you think is going to be printed out? It'll be an error. It'll be printed out something. It'll be some garbage. So it'll be undefined behavior. Undefined behavior. Why? Because when I executed the foo, it so like compiler, not a Java virtual machine, but the processor, right? So it came over here. It created the integer called n equal to 5. It assigned P to be the address of n, and then when this is exited, n is being destroyed. But P is a global variable, right? That's why P is not destroyed. N is destroyed and P still points to n, which doesn't exist anymore. And that's why if I try to print out what P points to, it will be undefined behavior. It will be an error. There'll be a mistake. Hope it makes sense. Okay, in a language with explicit reclamation of heap objects and dangling reference is created whenever the programmer reclaims an object, to which pointers still refer. Let's have an example. Int pointer p is equal to new int. Okay. Then pointer p is equal to 3. That means like we're creating a pointer p. Okay, so then we assign in the value to what p points at, right? So which is 3. Okay, and then cout, so console out star p. Okay, so that's going to print out what? Of course 3. Okay, no problem. Then we're going to delete p. Okay, and then cout star p. What is going to happen? Undefined behavior. Okay, because you deleted p. Okay, because star p was reclaimed. Star p was reclaimed. Okay. Note that even if the reclamation operation were to change its argument to null pointer, this would not solve the problem. Okay, so if you have like an object, you have some pointers, right? So if you change that pointer to point into null, that wouldn't really solve it, because other pointers might still refer to the same object. Okay. Now coming to the next topic, garbage collection. Garbage collection. Okay, so there's always again a trade-off between garbage collection and just like doing everything manually, because again, if you create a garbage collector, that, well, first off, it's very difficult to do. Okay, you need to think about all possible combinations of what user wants, and like when to delete an object, when not to delete an object, because again, like how do you know if an object is not useful anymore? If you don't have any references, it doesn't mean it's not useful. That's actually one of the ways of thinking about it, but it's not necessarily true. Okay, because you may be creating because you may have other references which have still some sneaky way to get to that object. Yeah. If you don't have any references which don't have any other references to that object, if you don't have any references which refer to references of that object, in that case, you may also think that that object is not valid and you can destroy that. So basically, that's the idea. So how do you know that the object is not useful anymore and you can safely delete it? So that's one. Another problem is that, for example, like it's very easy to miscalculate the addresses, and for example, you'll be like erasing part of an object, although you of course you don't want that. If you're doing everything manually, then of course, like you have to do everything manually, which means you have to remember all the objects you allocated. You need to remember you need to remember to deallocate them when you exit the program. Okay, that's also an issue. Like just to keep everything in mind, because your brain is limited as well. Your attention span is also limited as a software developer. Nowadays, of course, garbage collection algorithms are so powerful that everybody's using them. Java, Python are like such good examples of that. But if you are creating some software which relies on super efficient memory usage, you basically operating under consumption that you will perform better. Your memory allocation algorithms will perform better than the default garbage collector. So for example, when I was at TI, what we were doing was that we wanted to multiply matrices as quickly as possible. Okay, and then the question is how big those matrices are, right? So we wanted to feed as huge matrices into like very tiny chips. Okay, so how can we do that? So we were recreating the garbage collector algorithm. So we were basically saying like, hey, in order to multiply our matrices, we know how it should be done better than the default garbage collector than the default garbage collection algorithm. Okay, so we're basically improving that. Yes. Cool. Explicit reclamation of heap objects is a serious burden on the programmer and a major source of bugs. Yeah. So, for example, if you are like reclaiming all the creating and reclaiming all the objects yourself, then of course it's very likely that you'll forget something like every now and then, and it'll be like huge source of bugs. For example, memory leaks. Right? Memory leaks and dangling references. They all happen, they all occur because some programmer forgot to delete something, or like either the pointer or the object or something like that. The code required to keep track of object lifetimes makes programs more difficult to design, implement, and maintain. Yeah, but again, in the majority of the cases, you'll be using the programming language which actually takes advantage of garbage collection. An attractive alternative is to have language implementation notice when objects are no longer useful and reclaim them automatically. Okay, and which is called garbage collection. Example graphics, sorry, IDEST, right? Which is garbage collection. Whew. Okay, so let's take a look at least one strategy on how to basically know in advance when to reclaim an object and when not to. Okay, so reference counts. Reference counts. Okay, so when is an object useful? Right, that's the question. One possible answer is when no pointers to that object exist. Okay? The simplest garbage collector, collection technique, simply places a counter. Okay, and that's why it's called reference counts, right? It simply places a counter in each object that keeps track of the number of pointers that refer to the object. Okay, to the object. Okay, so when the object is created, the reference count is equal to what? Is set to 1 to represent the pointer being returned by the new operation. Okay. When one pointer is assigned to another, for example, like in Java, if you create two arrays, right? So arrays are not primitive data structures, okay? So those are already like more complex data structures. Let's say you create array 1, array 2, and then you can say array 1 is equal to array 2. Of course, in this case, you're not copying the content from array 1 to array 2 or array 2 to array 1. You just make two pointers point to the same thing. So now the reference count would be equal to 2. When one pointer is assigned to another, Yeah, hold on. Yeah, one is assigned to another. The runtime system decrements the reference count of the object referred to by the right hand side. No, hold on. No. When one point is assigned to another, the runtime determines the reference count of the object formerly. Yeah, hold on, yeah. Object formerly referred to by the left hand side. Yeah, left hand side. And increments, so side, right? And increments the count of the object referred to by the right hand side. Okay, so again, let's say you have two arrays, right? Array 1 and then array 2, and let's say we're talking about Java, right? Okay, so now if you say array 1 is equal to, okay, array 1 is equal to array 2, what's going to happen is that the address of array 2 will be the same as the address of array 1, okay? Which means that array 1 will not be pointing to the array 1 anymore. Array 1 will be pointing to the array 2, okay? And in this case, the counter for the array 2 should be increased because now array 1 also points to array 2, but the counter for the array 1 should be decremented by 1 because array 1 as a name, as a reference, does not point to array 1 anymore, it points to array 2 now. Hope it makes sense. Okay, yeah, right hand side. Okay, on subroutine, return the colon sequence epilogue must decrement the reference count of any object referred to by a local pointer that is about to be destroyed. When a reference count reaches 0, okay, so what do you think is going to happen? If, let's say, I have an object like array 1, there were like 3 references, there were 3 pointers pointed at array 1, and now if I like dereference them, so if I delete like each one of those references or I make them point to something else, okay, then technically there are no references, there is no way to reach array 1 anymore. So the question is like, why do you need that? Probably you don't need it. Yeah, so when the reference count reaches 0, the object is reclaimed. Recursively, the runtime system must decrement counts for any objects referred to by pointers within the object being reclaimed. Okay, and reclaim those objects if their counters reach 0 to prevent the collector from following garbage addresses. Each pointer must be initialized to null at elaboration time. Elaboration time. Okay. Yeah. So the most important problem with reference counts stems from their definition of useful objects. Okay. While it is relatively true that an object is useless if no reference to it exists, it may also be useless when references do exist. And that's not a problem. So if you have reference, but like that reference is never used, for example, then the object is never used, then maybe that's also a good time to reclaim the object. Okay. And then there is a figure. Yeah, for example, yeah, check this out. Let's say we have three objects. Okay. So one object, second object, third object. Okay. And let's say each one of them has a reference counter. Okay. Okay. And let's say they actually also point into each other. So something like, I don't know, linked list maybe? I don't know. Anyway, okay, so we have, so this guy points to this one. Okay. So like this object contains a reference to this one. This one points to this guy as well. Okay. And now this guy also points to this one. Okay. So there is kind of like a circle. And there is something with like outside of all of that, which has a pointer, like where is the pointer which points to like one of the elements of the circle. So now if we try to count the references, so this will be 2 because it has like two things pointing at it. There'll be 1, and this will be also 1. Okay, that makes sense. So now, and let's say that is, I don't know, something. Okay, now what if we decide to delete? Hold on. Okay, what if we decide to delete this? Sorry, no. Let's say we decided to delete this link. In this case, what's going to happen is we would also need to delete. We would have to change the reference counter from 2 to 1. Okay, so technically, all of those 3 elements are useful by that definition because the reference counter is 1, but the entire object, the entire circle is useless. Okay, so that would be a good moment to delete the whole thing, right? Because yes, I mean, like they have the counters, they have references to each other, right? But they create a circle, and there is no way to enter that circle, and that's why the whole thing can be deleted. So that's one of the examples of that. Okay, cool. Okay, let's stop here. Hope you guys enjoyed that. I'll see you guys next time. Stay safe. Bye bye.